This presentation is about our proposed algorithm to quantify facial expressiveness and how it can be used to perform affective behavior analytics. My name is Taufeeq. I'm a CS PhD student at the University of South Florida. In here, I have a series of video frames from this dataset. And if we move from left to right, what we can see in here is that the level of expressiveness wasn't the same. In this work, you want to quantify the expressiveness or expressivity at the video frame level. To do so, we come up with a video analytics framework in which we are going to feed in a video, and then we are going to compute the facial features such as facial action units, landmark, head pose, and eye gaze. Once we have all of this information, we are going to feed in all of this information to the proposed algorithm to compute the facial expressiveness score at the video frame level. And then we are going to combine the score with many other affective computing features or information such as demographic variables to perform affective behavior analytics. The proposed algorithm combines spatial expressiveness and temporal expressiveness. To compute the spatial expressiveness sigma, we are going to use facial muscle movement or action in it, and we are going to pay more attention to the most intense muscles. And we are going to keep the sigma in between 0 and lambda. Then we are going to compute the temporal expressiveness score, and we are going to pay more attention to major changes. First, we are going to compute the velocity between two consecutive frames. Then we are going to perform Taylor series approximation to estimate temporal expressiveness. And we are going to put a bound on it to keep it in between 0 and 1. Finally, we're going to combine sigma and delta to obtain the final expressiveness score tau. Note that temporal expressiveness delta was computed using 3 different modalities: landmark, head pose, and eye gaze. In this work, we experimented 2 different datasets: Biban pain dataset and a disparate dataset. Here is an example expressiveness score computed using these video frames. As we can see on video frame number 1, we didn't saw a lot of expressiveness, and the expressiveness score is really low. And in the video frame ID 325, we are seeing a lot of expressiveness, which was also reflected in our final expressiveness score. To evaluate the effectiveness of the proposed algorithm, we use human rater to rate the algorithm, and we found that the proposed algorithm was pretty good at computing the expressiveness score. The proposed algorithm is task agnostic, and it's only rely on face video data, which makes the algorithm really useful to perform downstream affective behavior analysis task. For example, in here, we summarize the Biban pain dataset across pain level using the expressiveness score. Here is another example behavior analytics task in which we quantify the differences between subjects using the proposed algorithm. In summary, we proposed a new algorithm to quantify facial expressiveness at the video frame level, and the proposed algorithm quantifies the expressiveness with a lower and upper bound, which is really useful for relative comparison. We experimented with 2 different public data sets, and we showed some example downstream tasks. To get more detail about the algorithm and also our experimental results, please take a look at our papers, and you can use this QR code to do so. Thank you.